This is a quick review on 8.3, a pattern of 4 triangles. So you should notice that you have a big square right here and that you have a smaller square within it, and then you have 4 triangles all around. So it says at the top you can use rigid transformations of a figure to make patterns. Here's a diagram built with 3 different transformations of triangle ABC. So what that means is I took this original triangle, ABC, and I applied different transformations to create this entire image. So very quickly, I'm just going to go through different transformations to get from one triangle to the next, and then I'm going to talk about corresponding parts briefly as well. So to go from triangle ABC to triangle CDE, so I already drew on my patty paper ABC. And to go from this triangle to CDE, there are a few different transformations that I could do. The one that I prefer is if I actually had my center of rotation in the center right here, I could rotate my paper 90 degrees to the right, and it's going to line up perfectly just like that, sort of how we did in the warm-up activity building for quadrilaterals. So that is how I went from ABC to CDE. And then if it wanted to know how I could go from, again, going from ABC to EFG, I'm going to use this same center of rotation, and I'm trying to get to the bottom triangle now. I'm now just going to turn my paper 2 times. So there's a 90-degree rotation, and then there is a 180-degree rotation. So you could probably guess how I got to the last triangle, GHA. And if you said either a 270-degree clockwise rotation, so 90 degrees clockwise, 180, 360 degrees clockwise, it lines up. Or instead of turning my paper 3 times to the right, you could have just turned it 1 time to the left. So when I look right here, a transformation would be a 90-degree clockwise rotation. For ABC to go to EFG, I did a 180-degree rotation. And again, it doesn't matter with a 180-degree which way you go. You could go to the right or to the left. And then from ABC to GHA, I did 270 degrees clockwise rotation. Or you could have said 90 degrees counterclockwise rotation. And either of those would have been correct. You also could have always rotated, say you could have rotated around point C. Oh, just kidding. You couldn't do that. Miss M is wrong there. But you could rotate it and turn it like this, and then translate it to the right and slide it up. So I think if you actually rotated it around A, that would have worked. Rotate it around A, and then slide it to the right and slide it up. That is also another transformation to go from ABC to CDE. So there's a bunch. I just chose the one of using the exact center as my center of rotation. Then the last thing said do segments AC, CE, EG, and GA all have the same length. So I'm going to highlight AC, CE, EG, and GA. And I asked if they all have the same lengths. So when we did those rotations, we noticed that all of their corresponding parts lined up. So if I told you that AC was 8 units long, when I rotate, this is my longest diagonal side on this triangle. It's also the longest diagonal on each of my triangles. Because they are corresponding, meaning that they line up with each other, all 4 of those sides are 8 units long. And that is what corresponding parts are. So I could have done the same thing with AB. And I could have said that was 4 units, which also means that CD is 4 units, which means that EF is 4 units, which also means that GH is 4 units. Okay, so corresponding parts are super, super important when we are doing transformations to make sure that we are aligning things with each other. That's why we've been talking about them so much this unit. So that is just a brief little summary again on corresponding parts, and then also when we rotate a triangle 4 times, how it is going to still create that same square. So if you have any questions, please let me know.